Hey, hello everyone. Welcome to the last video, clustering analysis. So, what is clustering analysis? Basically, this is an unsupervised learning technique where typically when you have some variables, let's say you have x1, x2, this is your data set with multiple variables up to xk, so you have k columns, and you have multiple observations, rows, 1, 2, 3, n observations. So in supervised learning, typically you will have a y variable, and this is like the output variable that you want to predict in supervised. But when we're talking about unsupervised learning, there is no y variable. So you don't have, at this point, you don't have like specific variable that you want to predict. But you have observations, you have data, you have multiple columns, multiple variables, and you want to get some insights from your data. You want to find patterns in your data. So clustering analysis is a technique that will help you to understand which of these observations are related to each other and what are the values of the variables that make those observations equal to each other. So it's a way to cluster our data, to aggregate our data, to understand some of the patterns in our data, again, without trying to predict a specific variable. It's just to get some insights. So clustering analysis is very useful. Actually, I would say that it's possible to use cluster analysis more than regression analysis and even classification. Why? Because in general, you can apply cluster analysis during your EDA. When you're doing the exploratory data analysis, it is possible to perform a cluster analysis just to explore your data. Now, what are the most common applications of cluster analysis? I would say that customer segmentation, this is a popular application. Actually, if you look it up, you will find that a lot of financial institutions, a lot of companies, they use clustering for their customers to understand like what are the groups of customers that behave in a similar way, so they can create some strategies to each of those to target each of those categories. It's like the idea here is like all your customers, they are not the same. So you need to offer some level of, like the service level is different, the benefit that you provide to some customers, they shouldn't be like the same to every single customer, because again, they are not equally important. All right, another important application is for anomaly detection. There are some specific clustering techniques. There is one, I'm going to write it here. DBSCAN, for example, this is a density-based strategy, DBSCAN. So it's a clustering technique that is helpful to find outliers in your data, some observations that behave in a different way. So you can identify noise in your data using these type of techniques. Data compression, if you want to reduce the complexity of your data set, for sure, so you can apply some clustering technique to reduce your data set. Okay, so in this video, I'm gonna cover like the most popular clustering technique, which is k-means. When you have linear regression regression problems, linear regression is the most popular algorithm. When you're talking about classification, logistic regression for sure is the most popular algorithm. Now, when you talk about clustering, k-means by far is the most popular technique. Why? Because it's simple to use, it's easy to understand. Okay, so what is the idea behind k-means? So we're given some observations, they are unlabeled initially, right? And after applying a clustering technique, the idea is to identify groups, right? To cluster your data, to label your data, because now you have like each observation. At the end, you will create a new column, which is called the cluster. So what is the group where that observation was assigned, right? In k-means, you need to specify k. K is the number of clusters. It can be 2, 3, 4, 5, or any other number. There are some techniques to identify k, such as the elbow method or the silhouette score. Those are the most popular methods to identify k. So let me give you a better idea of how k-means work. It's simple. So initially, this is the first figure. You have your data, it's unlabeled. You have your define k. So here we're defining k, in this example k equal to 2, right? So randomly the algorithm is going to create two centroids, or 2 points. So these 2 x's. This is the centroid of the clusters, or the groups. Now initially they are created randomly, right? But now in the next step, what's going to happen is, like, each observation is going to be assigned, or each dot is going to be assigned to the closest centroid. So for example, this one is closer to this one. So you perform the same idea. That's why you see the colors, right? So blue, they go, or purple. I'm pretty bad with the colors. So this is what is happening. So each observation is assigned to the closest centroid, and once you have finished that, then you need to recalculate the coordinates of this centroid. So using the points that were assigned, so here we have 2 coordinates, x1 and x2. So for example, for the red dots of the red observations, you take the x1 of those observations and you find the average, and same thing with x2. You find the average of those observations. That's why the centroid is moving and it's getting closer to the points, or it's getting closer to most of the points within the cluster, right, within that group. So same thing with the blue or purple x. It's moving closer to the observations of the second cluster, right? But if you notice here, there are still some with the new centroids. Again, we need to find which points are closer to the new centroid. So at this point there are some red dots, but they're going to change the color because now the blue x is closer to the red points. So that's why you see here in the next frame. Now it makes more sense. If you see, like, all of the observations are here and here. Now when you compute again the coordinates of the centroids, the x is going to move, like, more like inside the cluster. Same thing with the blue one, it's going to move inside the cluster like this, right? Now when k-means stop, when do you stop k-means? There is at some point the observation, they are not going to change from the cluster. They are, like, they are where they should be. So if the observations are not moving to a different cluster, then the k-means is going to stop, because there is nothing to recalculate, right? Because if you have the same points, the same observations, then when you compute the coordinate of the centroid, they are the same. So there is no need to keep updating the centroid information. So here is when the algorithm converges, right? Now like, each observation, you can label it. You can add to which cluster it belongs. So this is the red cluster and the purple or blue cluster, right? So that's the idea of k-means, to find for each observation, which is the cluster where other observation looks similar to that one. Now, most of the people believe that the cluster analysis is gonna finish at this point, but actually this is just the beginning. So once you have labeled your data, once you have found the cluster of your observations, then the most important part is to do some clustering profiling, is to define some strategies or policies to each cluster. So that's where everything makes sense, because, I mean, there's no point just in doing the calculation. What really matters is that you can make decisions, take action, right? With the cluster analysis. So you do that in the clustering profiling. Pretty much the clustering profiling is just to perform an EDA to each cluster group to find, like, why they are equal to each other, or why they are similar, what are the differences between the clusters, so you have a better understanding and more insights in your data, so you can create those policies or strategies. See, here we have the steps. It's the same thing as we just mentioned in the previous slides. So we have the initialization, where we define k clusters. Then there is assignment step. So for each data point, we find the distance from the observation to the centroid, to the closest one. We update the coordinates of the centroids, right? That's why the x was moving, closer to the observations. Then we repeat until there are no more, like, updates, right? Until all points are where they should be. So that's when we stop, and then we get started with the clustering profiling. So in the clustering profiling, as I was mentioning before, is where we examine our cluster centroids. We analyze the mean values. We find, it's like an EDA again. We find the distributions of the variables inside each cluster. We identify the key differentiators, like for each variable inside the cluster. We make interpretation, for example, and we will see that in the next slide. If we're analyzing customers, so you can find high value customers, frequent shoppers. It is important to validate the profiles, so you need context. The context is really important because if you know the data, if you know the real life, like where the data comes from, you will be able to connect whether those groups, those clusters make sense in real life. So that's the validation part. So this is an example, customer segmentation. So let's say that here we created 3 clusters, right? We were able to identify three groups. One is the bargain hunters, so customers who spend low amounts but purchase frequently. Cluster 2 is high value customers, customers who make fewer but high value purchases. They are really important. And cluster 3 is seasonal shoppers, so customers who shop mainly during specific times of the year, like Christmas and things like that. So you can create like different strategies for each group, and that's the beauty of this. That's the idea of the clustering. It's like not all my customers are the same. They have different needs, they have different patterns. So the idea of these techniques is to identify those differences, so we can act, like in a way in which we can get benefit from that. Like we can target our customers in a better way. Okay, so let's go to Colab, to Google Colab. So we can go over the code. Okay. In this file, we have the most of the library that we have used before: pandas, matplotlib, seaborn, scikit-learn. Remember that we have used scikit-learn for regression analysis, classification, and now for clustering. We read our data, US crime. This is our data. I will show you what is this about. So in our data we have the states in the US: Alabama, Alaska, Arizona. Like we have 50 states here. And then there are 4 columns. They are metrics like murder, assault, rape. These are like rates, like number of occurrences for every like 100,000 residents in the state. This is an old data. It's like a 50 years old data. It's like from the 70s. Yeah, it's from the 70s. Okay, so again, we have murder, assault, and urban population is just like the percentage of urban population in the state. Okay, so the idea in this data set is like, imagine that you're a decision maker, you have like a budget, and you want to invest some resources in to improve the safety in some of these states. So you need to prioritize, right? So that's the idea, to cluster them, to see like, okay, which states are, like with higher crime rates and things like that. Okay, so you can perform a basic statistic analysis, the descriptive statistics, with the describe of the dataset. So we get the mean value, standard deviation, mean, max values, some quartiles. All right. So the first step, and this is really important when we're doing a cluster analysis, like please notice that the variables, they have like different, the scale is different. I mean, for example, murder, if you check this column, the values are 13, 10, 8, but now you compare those values with assault, it's like this is 236, 263, so they are in different scales, right? So it doesn't make sense to combine them in the same distance unless you standardize the data before. So it's important to pre-process your data so you can standardize the data in a way in which they are treated the same. So that's our first step here. So we use the we scale our data, we transform our data to standardize the data. So pretty much what we're doing here, we load our standard scaler, and then we provide the data, and we are storing that data in scale data, right? Here we're dropping the first column. This unnamed column is just for the states, unnamed. These are the states. So we remove that column because that's you have text in that variable. So yeah, you cannot standardize that column. So we need to remove it. So once we remove the data, we can see the scale data. So each column now will have the mean equal to 0 and the standard deviation equal to 1. So pretty much what we do here is just we take each value and we subtract the mean value for the column, and we divide over the standard deviation. That's, remember the z-score. Do you remember for normal distribution, the way you standardize when you compute the z values is the same here. So this is data standardization. So the good thing is that now every single column has the same mean value equal to 0, and the sigma is equal to 1 again for each column. So now it makes sense to combine them to compute distances. So once we have standardized, we can perform our clustering analysis, our k-means. So this is the method from scikit-learn, k-means. So the parameters, the most important one, it's number of clusters, n clusters. Here I'm using 3, but you can test multiple values, 2, 3, 4, 5. Now, it doesn't make sense to have like a lot of clusters. For example, here we have 50 observations, but it doesn't make sense to have, let's say, 40 clusters. That's too much. I mean, to manage 40 groups, to create strategies for 40 groups, that doesn't make sense. That's a lot of work. So typically, the idea of clustering is just to get insight from your data, make decisions, but you want to have like a number of clusters that you can manage. Now, you need some practical considerations, like the one that I just mentioned, but there are also some technical considerations, such as the elbow method or the silhouette score that can help you to identify or to compute the number of clusters. For now, I'm just using 3. Random state, this is just a parameter to get the same values, but this is not relevant in the technique. There are other interesting parameters here, like for example the way in which you create or the way in which you assign the initial centroids. Like you can just create randomly the centroids, or you can create them conveniently. Like there is a technique here. I think it's like clustering plus. I don't recall the exact name. We can check it. The idea of that technique is not just to create the centroids randomly. The idea is like to ensure that they are not close to each other. It's like it guarantees that they are like like in different parts of the data. So a cluster will not absorb another cluster. Okay, so once we load the algorithm here, k-means, then we need to provide the data here, the scale data, right? And I'm saving that data in a new column, cluster, because we're labeling the data. So with k-means .fit predict, what it will give is it will give you for each observation, you get the information to which cluster it belongs. So for example here, Alabama belongs to cluster 1, Alaska to cluster 2. So here we have completed our clustering analysis, the k-means. So we have 3 clusters, 0, 1, and 2, because we said k equal to 3. If you change it to 4, you will get 0, 1, 2, 3. Alright. So now you can see which observations belong to the same cluster. So Alabama and Arkansas, for example, and Georgia, they belong to the same cluster, only considering these 4 variables. In cluster 0, you have Connecticut, Delaware, Hawaii, Idaho. Now, you cannot just like go over every single observation. Here, there are only 50. So it's simple to check the data. But in real life, you might have like 100,000 observations. So yeah, it doesn't make sense to go over every single observation. So this is where you perform your clustering profiling. It's just like an EDA of your groups. Now that you have this information, the cluster column, you can group by that cluster column, and this is what I'm doing here. I'm just computing the mean value here, right? The mean value, but you can find other descriptive statistics, and you can use some plots to kind of like compare the clusters. I mean, like an EDA, as I just mentioned. So, and you should do that for sure in your clustering analysis. So here we find cluster 0. In cluster 0 we have the murder rate. It's the lowest, right, compared to the other two groups. It's like less than half, right? It's less than 50% of the other groups. Assault is also lower. The urban population is like in the middle, and the rape rate it's also the lowest value. So cluster 0 will find at that time those states were safer, let's say, compared to the other states. Now on the other hand, we have these two states, for example, cluster 1 and cluster 2. In cluster 2 we have murder rate, which is high, twice cluster 0, a little bit more. The assault rate, it's also now is the highest, the highest urban population, and same thing with rape, is the highest value. So the idea here is now you can, as a decision maker, start identifying, okay, so this group, for example, it's not in danger, but this one, for example, is a little bit more critical, or it depends, because, for example, maybe for you, I believe that maybe the first variable, murder, is more important, so maybe you will focus the cluster 1. So this is, this is where you start making decisions and prioritizing your groups and getting deeper into your data. But at least now you have some insights, right? Because now you're not looking at 50 points, you're looking at 3 groups. And you're trying to make decisions for those 3 groups. Alright, so I'm gonna stop the video here. I hope you enjoyed the cluster analysis. I'll see you in the final test.